So when we talk about the word radical, so radical is just another name for the square root symbol. And so we've seen the square root symbol before. In fact, we were doing some work with that earlier in the week when we did the square root method. And so here are some examples of seeing the radical symbol around some numbers. We actually have a list of all perfect square numbers here at the top. And so let's start to fill these in. Today we are just going to think about the positive version of the square root. We don't need to worry about putting the plus or minus sign in here right now. So we're just going to think about, like, the square root of 4 is 2, because 2 squared is 4. So the square root is undoing the square. So let's go ahead and fill in the rest of these. The square root of 9 is 3. The square root of 16 is 4. Square root of 25 is 5. We have a little pattern here. We're just going up by 1. Square root of 36 is 6. And then the square root of 49 is 7. So what if we had something else like the square root of 12? Well, we know that 12 is not a perfect square number. And when we saw this earlier in the week and we got to something like the square root of 12, we said, well, we don't want to deal with any decimals, which is still true. We want to leave this in exact form, so we're going to keep the square root symbol in the answer. But what I want to show you today is that sometimes it is possible to simplify the radical, simplify something like the square root of 12, and that would look something like this. It's going to involve finding factors that multiply to 12, where one of the factors is a perfect square number, meaning perfect square numbers like 4, 9, 16, or 25. Those are the most common ones that we want to look for. So if I think about 12, I know that I could divide that by 4, and 4 is a perfect square number. So what I'd like you to write here is like a bigger, longer square root symbol. Underneath it, we're going to write 4 times 3. That's an equivalent way of saying the same thing because 4 times 3 is another way to say 12. Then what we can do is we can actually split this a little bit further. So we can split this up into the square root of 4 times the square root of 3. When you have the square root of elements underneath that are being multiplied together, you could take the square root of them separately and then multiply those. Now, finally, we're going to get to the part where we can simplify, because the square root of 4, we did that earlier, that works out perfectly to be 2. So I'm going to write a 2 in place of where the square root 4 was. Now, I still can't do anything else with that square root 3. There's no way that we can, like, split apart the 3 or go any smaller than that. So this is going to be our final answer. So what I want you to see here is that the square root 12 that we started with at the very beginning, that is equivalent to 2 times the square root of 3. Now, if you were to type these into a calculator, this is not a normal thing that we're going to do because this whole unit we're going to avoid decimals. But I just want to show you something real quick on my calculator to convince you that this process works. Those two values really are the same. So if I want to do the square root symbol, on a graphing calculator, I can press the second key up here in the corner, and then I'm going to find this key right here. It looks like an x squared, but there's a square root symbol above it. So I'm going to type in the square root of 12, and again, it's this messy decimal, which is why we avoid that, but it's about 3.464. And then down here, if I type in 2 times the square root of 3, notice how it's exactly the same thing. So 2 times the square root of 3 is going to be the simplified form of the square root of 12. Now, I want to say here that we do need to be careful in how you split apart your number. So I chose the factors 4 and 3 very carefully because I wanted one of the factors to be a perfect square number. If I were to split this into the square root of 6 times 2, technically so far, there's nothing wrong about this statement. These are still equal because 6 times 2 is still 12, but then we're going to get stuck because if we try to do the square root of 6, we can't do it. If we try to do the square root of 2, we can't do it. So I'm just going to make a little note here that this gets us nowhere. We're not actually able to simplify because 6 is not a perfect square and 2 is also not a perfect square. So let's, oh yes, okay, sorry. So that's a great question. You only need to have one of the numbers to be a perfect square. But let's go ahead and fill this in here, that we do want to make sure that we have at least a perfect square value as one of our factors. And when we're referencing this word perfect square, I'm going to actually write this up at the top here, off to the side. This is what we mean by perfect square numbers. So numbers like 4, 9, 16, 25, and so on. Because that's what we did up at the very beginning. It's numbers that we can perfectly take the square root of. All right, we're going to take a look here at one more example together. So we're going to look at the square root of 32. And we're going to start off in the same way by finding factor pairs that multiply to 32. I'm also going to think about trying to make sure that one of my factors is in this list of being a perfect square. One way that I can get to 32 is 4 times 8. And what's nice about that is 4 is a perfect square number. But what's interesting on this one is that I can also make 32 by doing 16 times 2. Well, 16 is also a perfect square. So this is an interesting scenario because now we have two options. It looks like there's two ways that we can possibly pick this up, or split this up. So which one should we choose? It's always better to choose the option that has the larger square number if you have two options. And that's just because it's going to get you down to your final simplifying form a lot faster. So let's go ahead and finish that one now. So if we want to simplify the square root of 32, I'm going to write it as the square root of 16 times 2. But then it's going to get split up. Square root 16 times square root 2. I can see here at the top that the square root of 16 is 4. And there's nothing that we can do with the 2, like we can't take the square root of that, so that's going to stay inside of the square root symbol. But what's nice now is that now we just have that 4 that's out in front. So the square root of 32 can be written in simplified form as 4 times the square root of 2. Now let's say you didn't choose the larger option. To split this up, let's say that you chose the smaller one. Here's what that would look like. So if you didn't think about 16 times 2 and you just only thought of the 4 times 8, well, you could split that into the square root of 4 times the square root of 8. That ends up being 2 times the square root of 8. But then what's interesting here is that the square root of 8 can be simplified further. So the square root of 8 is the same thing as the square root of 4 times the square root of 2, because 4 times 2 is 8. Well, let's look at this. Now that's going to give us another 2 in front. Here we have our square root 2 at the end, but we still have the other 2. These are all being multiplied together. Now notice how the 2 times 2 in the very front is still 4. So we're still going to get to the same answer. It just wasn't as fast. We had to do a lot more steps. So that's why I like to recommend choosing the larger option if you're able to. We want to ask ourselves this question of, can this be simplified? And if you don't immediately recognize something that it divides by, you could always just grab a calculator. So for example, if you got to 27 and you were having a hard time thinking of what those factors were, you can just start at the top and just try dividing 27 by all of the perfect square numbers. 27 is kind of a small number, so you might recognize it sooner, but you might have something that's much larger that you're just not as familiar with. Typically, it's going to be one of these. It's going to be 4, 9, 16, or 25, and you'll be able to see if that works or not, and that can help you to get this split up. So you will have a calculator with you when you're solving these. We still have a calculator for this whole unit, so that can be helpful. Now, let's take a look at the one here at the very bottom, the square root of 26. If we try to think about factors of 26, the only options we have, well, 1 times 26, or we can split it into 2 times 13. If you try to divide these 26 by any of these square numbers, we're going to find actually it doesn't work. And we can't do anything with the square root of 2 or the square root of 13. And so this one is just not able to be simplified. So I just want to remind you here that we're not always able to do this. It only works out sometimes depending on what the factors are that make that number. So I'm just going to make a little note here for the square root of 26 that this one just can't be simplified. If we saw the square root of 26 in an answer from an equation that we were solving, we would just keep the square root of 26 there. We don't need to worry about trying to simplify it if the numbers don't work out to do that. The reason that we are looking at these problems here at the start is because when we start to solve some more equations today with that quadratic formula, we are going to encounter some solutions that have a square root symbol in the answer. And anytime we see something that's a number, a square root of something that we can simplify, we're going to start to get into the habit now of getting it simplified down all the way. All right, so let's talk about the quadratic formula. So let's go ahead and turn your packet over to the next slide. And we talked at the very start how this is going to be now a new way for us to solve a quadratic equation. Now, similar to what we did with completing the square at the beginning of the week, it has to be in this format in order for us to use the quadratic formula method. It kind of looks like standard form, where we can identify A, B, and C. Notice that we do not have any parentheses, and A is whatever's in front of the x squared, B is in front of the x term, C is the number at the end. Notice how it is equal to 0. So if your equation is set up in this way, and you can identify what those values are for A, B, and C, this is how you can find the solutions, meaning solving for x. So we're going to go ahead and start this with an x equals out in front. And this is going to actually be, it's going to look like a big fraction. And so I'm going to draw a big, long fraction bar, and we're going to start to fill in just the numerator part. So on the numerator, it's going to be negative b, whatever the b value is going to go behind a negative sign. Then we are going to put in our plus or minus sign that we saw earlier in the week, followed by a big square root symbol. Underneath the square root symbol is b squared minus 4 times a times c. That's the entire numerator. The denominator is much simpler. It's divided by 2 times a. Now, the quadratic formula is something that we want to learn and eventually memorize so that we can use this to solve quadratic equations. There are a lot of songs. There's a lot of quadratic formula songs out there. In fact, if you do a simple YouTube search, there's videos made, there's like all types of songs. There's rap songs, there's all sorts of songs. And I'm going to actually share with you, I always sing this to my class every year because this is how I have learned and remember the quadratic formula. So I learned this song when I was young. It goes to the tune, like I told you, there's a few different versions, but mine goes to the tune of Pop Goes the Weasel. And I'm probably going to spell weasel wrong. I'll try. I think it's like this. So question mark there for the spelling. But this is the song, and honestly, I think about the song. I sing it in my head as I'm doing it right now, and it helps me to remember. Songs can be very, very powerful for memory, even if you're thinking, that sounds really silly. Maybe it is a little silly, but I promise it can help you learn it. So it goes like this, and I am recording this, so if you want to go back and look at the song, we're at about 15 minutes in our video. I'll just say that. Okay, so it goes like this. X is equal to minus b plus or minus square root b squared minus 4ac all over 2a. That's the song. All right, so that's what you can think about. That's what helps me to remember this. If you do want to check out some other songs or videos, like I told you, do a search. There's a ton of them out there. Okay, so before we're going to finish today by solving some equations with a formula, but I want to take a few minutes here. I always show this to my students every year of where the formula comes from. And it's important, I think, to know that when we have these different formulas and equations, they're not just random. There wasn't just some mathematician sitting in an office trying to think of, like, what's a way that I could combine the A, B, and C together. There's a very specific way that the formula is what it is. And what's really cool about this is that it comes directly from the process of completing the square. It's just a generalization of the completing the square process that we did earlier in the week. So it's like saying, if we want to solve by completing the square, let's say we don't know what the numbers are, we'll just call them A, B, and C. How can we make this process still work? And then what results is the quadratic formula. So I have on your paper some boxes with some space for you to write out the steps. But know that this is not something that I'm going to be testing you on. I just think it's valuable and helpful for us to see why this works and where it comes from. So step one is going to be really similar to what we did at the beginning of the week. So we always talked about starting by moving C over to the other side. And so I'm going to do that by subtracting C from both sides. So I'm essentially going to write the same thing that I started with, but then I just have a negative in front of the C because it was originally adding C, so I'm going to subtract it. Now let's take a look at step two. So remember, we didn't actually need to do this on Monday when we were solving our equations, but we mentioned it that if you have an A value out in front of x squared that's not 1, we have to divide everything on both sides by A before we can complete the square. So when I do the first term here divided by A, the A's are going to cancel, so it's just going to leave me with x squared. You can also think of it as being like A over A in front of the x squared, but A over A is just equal to 1. Numerator is the same as the denominator. Now for the middle part here, I'm going to do bx divided by A. Really, for that, I just need to do b divided by A and keep that in front of the x. And then on the other side, I'm going to do negative c divided by A. So that would be how we would get rid of any number other than 1 that might be in front of the x squared. Okay, now the next step. So I gave you a big box of space to write this one. This is where we are going to complete the square. So I want you to hang with me. I know it looks different because we don't have numbers, but it's exactly the same process as what we did on Monday. So that b over a, that just represents some number. And we saw earlier in the week, whatever that number is that's in front of x, we need to divide that by 2, and then we square it. So here's what that would look like. If I want to do a fraction divided by 2, I can write that like this. And I'm still going to write that the whole thing is being squared. Now, the way this works out, b divided by a divided by 2, now it looks like the b is being divided by 2 things. Well, mathematically, what we can do is actually just keep the b up on the numerator. Because it's dividing by both 2 and a, we can just put the 2 and a both together down here on the denominator. So that would be our in-between step. Now, we have a fraction that is being squared. And so squared means multiplied by itself. Well, if we multiply a fraction by another fraction, we multiply across the numerators, and we multiply across the denominators. So it's kind of like we're going to square the numerator. We're also going to square the denominator. So when this gets inserted back up into our equation, the numerator, so let's do a plus sign, it's going to be positive. The numerator is b squared. And then on the denominator, in order to do 2a squared, it's going to be 2 times 2 times a times a. So that's going to turn into 4a squared. Now, because we just added that component on the left side, brand new, it wasn't there before, we need to make sure that we also add that to the other side. Okay, so we've done step 1, 2, and 3. Now, the whole point of completing the square right here is turning this into something that we are now going to be able to factor. So we're going to factor it into something that looks like this, a quantity in parentheses that is being squared. So let's think about factoring this. It's just another perfect square trinomial, the same way that we've always done. So let's do the square root of the first term. The square root of x squared is x. So that's going to go in the middle. Now the middle term here is being added. So we're going to bring down a plus sign. And then we're going to do the square root of the last term here. Well, let's talk about how you can take the square root of a fraction. You just take the square root of the numerator, put it on the numerator, then you take the square root of the denominator, and you put it on the denominator. So if we square root each part, the square root of b squared is b, and the square root of 4a squared is 2a. That's actually not too surprising, because we saw this earlier in the week with numbers. Whatever we have right before we square it, that's always the number that is going to go here in the parentheses. Okay, so that is the left side factored. That side is done. Go ahead, Josh.
Isn't the square root of 4a squared?
Okay, now let's get back to our process here. We do still have to do a little bit more work on this right-hand side. It's not going to be as simple as just like easily adding these together because we don't have numbers. We're dealing with fractions. In order to add fractions together, the denominators have to be the same. And right now they're not the same because the first denominator is a, the second denominator is 4a squared. And so in order to get those denominators to be the same, we could keep the second denominator as it is. All we would need to do here to the first fraction denominator is we need to multiply that by a 4, and then we need to multiply it by another a to make it an a squared. Well, whatever we do to the denominator, we have to also do to the numerator. So I'm going to multiply by 4 on the top, and I multiplied an extra a on the bottom. We're going to multiply by another a, so it's going to be 4 times c times a. Okay, so now our denominators are the same. The way that we add fractions is we add across the numerator, we keep our denominator the same. So let's do 4 times c times a plus b squared all over 4a squared. Okay, so we're almost done. So we are at the point of the completing the square process where we are ready to do the next step, which is to take the square root of both sides. So when I take the square root of the left side, this is going to be really simple because it's just going to undo the squared symbol outside of the parentheses, and that's going to leave us with x plus b over 2a. Now let's talk about how we are going to square root the other side. We saw this a little earlier. If we're trying to take the square root of a fraction, we're just going to square root the numerator, and we're going to square root the denominator. We also need to make sure that we have the plus or minus sign out in front of our answer. Anytime we introduce a square root symbol into the problem is when we put the plus or minus sign. Now, there's nothing that we can do on the numerator part. We cannot take the square root of those pieces, even though b squared is a perfect square. Remember, we just said, well, there's a plus sign here, so we're not actually able to square root anything. So we're going to leave that exactly as it is. Now, to make this look a little bit more like the quadratic formula, we're going to rearrange a few things. So, for example, instead of putting that positive b squared at the end, we're going to move that to the front. And the minus 4 times c times a is going to move to the back. But instead of doing c times a, let's actually change it to be a times c. Now that's more familiar. That's what we see in the quadratic formula. Now on the denominator part, when we take the square root of 4a squared, the square root of 4 is 2, and the square root of a squared is a. All right, the last and final step here is to solve for x. So that just means that we want to get x by itself. So we need to subtract b over 2a from both sides. And to make it look like the quadratic formula, instead of subtracting b over 2a from the end, I'm going to actually write that out in the front. So it's going to look like this. Minus b over 2a, plus or minus. The whole big second fraction that we wrote is going to stay the same. Now the final thing here, because these are fractions that are either being added together or subtracted together, this is going to represent two different solutions. As long as you have the same denominator, you just add or subtract across the numerator. We have the same denominator. It's 2a for both of them. And so what we can actually do is write this as just one statement. Instead of it being two separate fractions with the same denominator, let's add across the numerator and keep our denominator the same. And that final result is the quadratic formula. Okay. So let's get started here. So let's begin by identifying A, B, and C. So this is how I always like to start. And I'm just going to list those numbers out, like right down below where they are. If you don't see anything in front of the x squared, then A is 1. Okay, and then for this first one, let's practice writing out the original formula in terms of A, B, and C, just so that we have that to look at in reference when we start to plug the numbers in. Sorry about that. Now you can actually see what I'm saying. So I just started out by writing out A, B, and C. And then I just listed out the formula. Sing the song, minus b plus or minus square root b squared minus 4ac all over 2a. All right, so that's our formula. Let's start to plug the pieces in now. So I'm going to still start with my x equals. I'm going to start with my minus sign. And the b, in this case, is positive 8. So when we plug it in there, now it's going to look like a negative 8. Plus or minus, square root symbol. 8 squared minus 4 times 1 times 12. Notice how we're using parentheses here to show that those pieces are being multiplied together. Then we're dividing it by 2 times a, so we're dividing by 2 times 1. Now, we just start to simplify. The main part that we need to simplify is everything that's under that square root symbol. We're going to think about order of operations here just for this part, which says we need to deal with the exponent first. So we're going to do 8 squared first. We can turn that into 64. Once we've done that, then we're going to multiply this string of numbers together here. So for example, 4 times 1 times 12 is 48. So on the inside here, we would have 64 minus 48. The subtraction part there is going to come at the end. So then we'll actually subtract 48 from 64. Let's write out the step here. So I'm still going to have the negative 8 in front. And I'm just going to write the results for both pieces here, just all at once. So 8 squared is 64. Bring down the minus sign. 4 times 1 times 12 is 48. I'm going to write that step. But then I want to actually subtract them here. So 64 minus 48 is 15. And by the way, on the denominator, 2 times 1 is just 2. That's why I just started writing it as a 2. Okay, so now let's look at the square root part. Is there anything that we can do with that, with the square root of 16? What can we do with it, Megan? It's just turn into 4. Yeah, so this one is kind of nice because it's a perfect square number. It doesn't always turn out this way, but sometimes it does. So if you can take the square root of your number, go ahead and square root it. So we have negative 8 plus or minus 4 divided by 2. Because we have that plus or minus sign in here, this is really representing 2 different answers. And so this is where we can split this up to show those 2 possibilities. It's either going to be negative 8 plus 4 divided by 2, or the other option is to do negative 8 minus 4 divided by 2. And we're going to figure out what this actually equals. So for either situation, we're either going to add across the top or we're going to subtract across the top. We're going to take that result and divide by 2. So let's look at the first one here. Negative 8 plus 4 is negative 4. Negative 4 divided by 2 is negative 2. So I'm going to go ahead and circle that. That's one of our answers. Now for the second one over here, negative 8 minus 4 is negative 12. Negative 12 divided by 2 is negative 6. That's it. So I want to remind you of a little something that we saw in that graphic organizer chart for the different forms of quadratic functions. We had vertex form, standard form, intercept form. So remember that when we have a quadratic that's in standard form, like this, we filled in a box for how to find the x-intercepts. And what we wrote in that box was quadratic formula. And I said, don't worry about this now. We're going to learn about it later. Well, today is the day. And the connection here between the answers we got on the graph and the graph looks like this. If we go to Desmos and type in our equation, just set it equal to y, notice that the answers are the x-intercepts. The x-intercepts are negative 2 and negative 6. So that's kind of another cool thing that the quadratic formula does. If it's in standard form, you plug it into the formula, you get the x-intercepts on the graph. So I'm just going to make a little note here wherever I can squeeze it in. It might be up here near the top. I'm going to draw a little x and y axis. Both of the x-intercepts here are negative, so I might put the y-axis a little further to the right. And I'm just going to draw a little parabola sketch. And I'm going to label -6 and -2 as the answers I got. I'm going to label them in the position of where the x-intercepts are. I'll put a negative in front of the 2. That'll make that better. So that's what the quadratic formula is actually doing for us. That's what it means when we're solving and getting our solution. One thing that's a little bit different in the next problem is that notice how it's not equal to 0. Right here it is equal to 2. And so we're actually not able to use the quadratic formula yet until it is equal to 0. And so we need to actually move this 2 back over to the other side. So let's actually start by subtracting 2 from both sides. So we get 5x squared minus 2x minus 2 equals 0. All right, for this problem here, what do we get for A? What's A? 5. Okay, what's B? Close. -2. And then what's C? -2. Okay. I want you guys to try this. If you want to rewrite the formula with A, B, and C like we did over here, you can. Or if you just want to look at what we did in the first box and then just try to start plugging the numbers in on this one, you can. What I would say, though, is be extra careful on this one, keeping in mind that we have a negative sign in front of the 2 for our B value. So think about how this is going to look if B is negative. So just take a few minutes there and let's just plug the pieces in where they go, and I want you to try to simplify it down as far as you can. So initially when we start to plug the pieces in for the negative B in front, so I'm going to think about there being a negative in front of this -2. We have plus or minus square root B squared minus 4 times A times C, all divided by 2 times A. Now, one small note here, I did not do this in the first one because I had a positive number for B, but if I have a negative number for B, I like to put these extra parentheses around the minus B and then also the B squared part, just so it's holding that negative sign in there. All right, so now let's start to think about simplifying this. So this is going to turn into a positive 2. In the very front, it's going to be a 10 on the bottom. And then inside of our square root, this is a place where we want to be careful. So it's going to start off the -2 squared, -2 times -2, so that's going to turn into positive 4. Now here's what's interesting. I'm going to go ahead and bring down that minus sign, but then I'm going to think about multiplying together these 3 numbers that were behind the minus sign. Well, if I do 4 times 5, that's 20. 20 times -2 is -40. But remember that it's being subtracted. So I'm actually subtracting -40. What's another way we can write that? Or what is it really the same thing as? Yeah, it's just the same thing as adding. So this is 4 plus 40. And that happened because we were subtracting a negative. So this is going to turn into the square root of 44. 2 plus or minus square root 44 divided by 10. Now this is going to be a little different type of answer than what we had before because I cannot do the square root of 44. It's not a square number. But I can simplify the square root of 44. So this is the skill that we did at the very beginning of today, trying to find a perfect square number that goes into 44. So I'm going to continue down here. I'm noticing that there's a 4 in there. I'm going to split this up into the square root of 4 times the square root of 11. I'm just going to hide some of this from the previous problem. We can just focus on the new one. And so that square root 4 in front is 2. and that's going to stay in front of the square root of 11. Now, sometimes, when we get to this point, then this is as far as we can go. Nothing else can be simplified. But in other cases, like in this one right here, we're actually able to reduce our fraction one step further. And it's kind of just like if you were reducing a regular fraction, like 4 over 16. The way that we would reduce it is we would try to find something that we could divide both the numerator and denominator by. That would get us a simpler fraction. Well, we can actually do the same thing over here. So I'm noticing that this 2 in the very front, along with that 2 that's in front, along with the 10 on the bottom, they're all even numbers. And so I could divide all of them by 2. And so this is what the final step is going to look like. Everything on the numerator will divide by 2, and everything on the denominator divides by 2. The only thing that we do not touch or ever change the number on the inside is the square root of 11. That is not getting divided by anything. That 11 is like untouched and unchanged. The only thing that is affected would be like the 2 that's out in the very front. So when we do each component divided by 2, the 2 in the very front divided by 2 is a 1. Bring over the plus or minus sign. The 2 in front of the square root of 11 also turns into a 1. The square root of 11 does not change. The denominator turns into 5. You can write it like this. One other option, though, is to not write the extra 1 in front of the square root of 11. You don't have to. If you just keep your answer like this, that's perfectly fine. Now, if you have one like this in the Math Excel assignment, remember that we don't do the plus or minus sign when we're typing in those answers. We would split this up and show the 2 possibilities. So here's what that would look like. It would be 1 plus square root 11 divided by 5, comma, 1 minus square root of 11 divided by 5. Okay, so there's one quick thing that I want to show you here on the calculator. We're always going to leave our answers here in exact form, which means we're going to keep the square root symbol in there. But look at this. If we were to put it into our calculator, the first possibility is about 0.863. The other one is about negative 0.463. That would be the decimal approximation. I show this to you because I want you to see, again, that these are still the approximate location of the x-intercepts on the graph of this parabola. So if I were to type this one into Desmos, and I'll switch over here and show you in just a moment, I'm going to take the same thing that we started with, I'm just going to put a y equals in front. And if I zoom in, notice how I don't have nice whole number x-intercepts like I did before, but look, if we click on them, those are the same decimals that we just got, 0.863 and negative 0.463. So it really is 1 plus or minus square root 11 divided by 5. Sometimes x-intercepts are not pretty perfect whole numbers, and that's okay. That's just what we have going on with the second equation. So they are still the x-intercepts on the graph. Very cool. Okay, we're going to finish up here. In the next 2 problems, one thing that's different that I want you to notice is the original form of these equations. This is not the form we want them to be in. First of all, they're not equal to 0. We cannot tell what's A, what's B, what's C. And so if we have something like this, we need to do some work to get it into the right form. So for example, we can start by getting rid of our parentheses here. So we could distribute the negative 3. And then we just need to get everything together on one side. It's up to you. It's up to you what side. I'm going to put everything on the left side. So I'm going to add 12x to both sides, and I'm going to add 9 to both sides. Also, when I do that, I get a b value that's positive, and I just think it's easier when b is positive and not negative. Okay, so just quick first step to get everything to equal 0. Okay, so let's put this into our quadratic formula. So we have x is equal to minus b, so that's going to be minus 12, plus or minus square root, b squared, minus 4 times a times c, all over 2 times a. Now 12 squared is 144. I'm going to bring down the minus sign. 4 times 4 is 16. And 16 times 9 is also 144. So what could happen is that it's the same number that's being subtracted, and that just equals 0. 144 minus 144 is 0. The square root of 0 is 0. If you add 0 on the end, or if you subtract 0 on the end, it doesn't change anything. So this one actually has a much simpler answer. I love this situation because there's no square root symbol. It's just one answer, negative 12 divided by 8. I would like to simplify that fraction if I can. Maybe we could divide the top and bottom by 4. So it's really just negative 3 over 2. So that one's nice. It's only one answer. Remember that the answer is supposed to be the x-intercept on the graph. Well, how could we only have one x-intercept? I'm going to type this one into Desmos, and then I will show you. So I've got 4x squared plus 12x plus 9. I'm just going to put a y equals in front. Really quick though, before we look at Desmos, what's negative 3/2 as a decimal? Okay, good. Let's just think about that, because Desmos is going to show us that x-intercept as a decimal. So when we take a look here at the graph, you can see that's the same equation that I typed in. If there's only one x-intercept, the x-intercept is the vertex. And sure enough, yep, it's at negative 1.5. Still means the same thing, there's just only one of them. Okay, so that's a situation that could happen. There's one last situation that we might see, and that's what we're going to look at in this last problem. Now, it's kind of like the one that we did before, where we need to get it in the right form first. When we do x multiplied by 5x, it's going to turn into 5x squared. X times negative 3 is negative 3x. And then I don't want that negative 2 on the other side, so I'm going to add 2 to both sides. Now it's equal to 0. All right, let's start to fill these pieces in. I have a negative b value again, so I'm just going to use some extra parentheses anytime I plug in the b. Negative, the negative in front of the negative 3, that's going to make it positive 3. The denominator here is going to be 10. And then inside of our square root, we get positive 9 minus, well, 4 times 5 is 20, and 20 times 2 is 40. So when we do 9 minus 40, that's actually going to go into the negative. It's negative 31, square root of negative 31. Well, there's something a little interesting about this. In the real number system, we actually cannot take the square root of a negative. It doesn't make sense. If we try to find what number squared is equal to a negative, it never works, because positive numbers that are squared are positives. Even a negative number that is squared, kind of like this one that we did, that also turns into a positive. It doesn't make sense. And so if you see something that is the square root of a negative, that's actually a number that we call an imaginary number. And we're going to talk more about imaginary numbers on Monday. This is just a little preview. The reason that we are concerned about it, that it comes about, is sometimes in our formula, we end up getting the square root of a negative. Now, you're actually not going to get anything that is an imaginary number on your assignment for tonight. We will look at some more problems like this next week. But I wanted to show you this just so we're aware of this possibility. And I want to show you what happens on the graph. So I went ahead and typed this into Desmos. And you know how the solutions are supposed to be the x-intercepts? We don't have any x-intercepts here. The vertex is way up high, and it's opening up. So it's never going to cross through the x-axis. So one thing that's really interesting here is when you end up getting imaginary solutions, there are no x-intercepts. And that's just a little note I want you to put there for that last problem.